Hello everyone, myself Mahesh. As everyone aware that if something new is coming, we already have some challenges in the implementation and all. So we would like to understand what are the biggest technological and infrastructural barriers to integrate AI into embedded systems in India and how can it be addressed?
Uh, Hello, everyone. Good afternoon. Just after the lunch session, it might be no that. So I need some energy from your end as well. So thanks, Mahesh. Uh, I will touch upon a very key aspect of technological barriers. So I will share my perspective of the organization which we work. We are a global leader into the platform OS software. Now, we cover varieties of industry, including automotive, aerospace, defense, and lot many critical industries in the embedded side. So Wind River holds that thing. But then coming back to the technological barrier considering the AI. So if you look at on the hardware piece in the complete the product, if you start with the silicon and there is a bare next layer when you are working on a critical system is the OS, which is in embedded world, it's a hard real-time OS. Now, I do not see any possibilities logically that you need to integrate AI agent or AI algorithms or AI models into the OS. Reason being, because if you're working on a critical industry, then only you are using the hard real-time operations. And to certify and meeting the specific functional safety compliances, you will not, you will need a very stringent kind of a no process to get your product certified. And if that product is getting into a very end product for an end customer, then it is a very tedious job. So I would never recommend to add any AI agent or algorithm into the RTOS. And even if it technically possible, I do not see that it getting certified or we do not have any policies or the implementation or any guidelines, because if you use this product into the aircraft or a missile program or even an autonomous vehicle or a very critical no, the industrial application where human is not needed. So this kind of AI, we cannot rely on AI algorithm or an agent when you needed a real-time response. So this would be a challenge I would see technically, because we are not going to validate the AI agent. Alongside, I am not seeing any possibilities that we need to do certain enablement in terms of certification side. So these are some of the challenge I do see. This is my perspective. Yeah.
So is there a ways to overcome these challenges or in future, because as it is going to evolve, obviously for this obvious questions, there will be answers in the future. So do you see any feasibility or possibility in the near future?
So Mahesh, yes, even in fact, I would see some audience sitting in this room would be already working on AI algorithms at the edge side. This is what the theme of the thing. But looking at the perspective of the artos, I do not see a possibility because this is never going to be adapted or accepted by the certification bodies. And we do not have any standard. Like if we talk about automotive, we have ISO 26262 functional safety. If you go back into the aircraft, it is DO 178. If you go with the medical, it's the FDA guidelines. If you go with the industrial, EN 50128. If you go with the railway, there is a SANELEX standard. These all are a software specific standard. But if you are working in a mission critical thing, this is not going to be accepted by the regulatory or the framework. Now, on your question, yes, this is possible above this layer. So when I say above this layer, it's a middleware or application layer where most of the companies are developing their software which generate, let's say it could be a generative AI or some specific AI enabled model. This is getting enabled. Now, there are advantage of doing this that is the companies are working on, because these models will actually pinpoint to a very specific set of data and do a very intelligent decisions. And this will help to reduce some of their workflows as well as the some of the time of the development. So I do see this is getting adopted already. This is getting accepted. The only thing, we do not have any framework to revalidate whether if I have generated a model from X company, whether is there any guideline over which I have generated. There might be a Y company who might have better model, but there is no as such framework. So this is getting adopted at the above layer, but not at the critical layer of an OS side. So this is the answer of your question. Yeah.
Okay, so in the near future, I don't think we can have some solution, at least for near future, maybe.
But you will definitely, all the people would be working at the application and the middle layer side to ease out their the innovation and the time of an innovation. So this is possible at the above layer. When I say above layer, it's a middleware and the application layer, not at the OS level.
Okay, so it means for the mission critical applications, AI might not be at the bottom level of the this integration, right? Oh, okay, okay, correct. Okay, so I'll move to the next question. As we know that AI is very compute intensive, so it needs a lot of power. So how do we address power consumption and latency issues in embedded AI to target the cost-effective segment? Like you already know that India is very cost-sensitive segment. So how do we achieve this?
So power consumption as well as latency are the critical things which we are seeing, and typically this is issue when it comes to cost sensitive market or cost sensitive solution. So I will break down this into two categories, hardware and software. So while designing a solution, design it such a way with the help of hardware components or integrated components which consumes less power. So it starts with design. And if we think about latency, uh, do edge computing rather than sending your data and computing it. So design it that way. And then it comes to software side. I would say do a code optimization. Uh, so the source code such a way, designed it in such a way that it should be not memory hungry. It should be locally computed. Uh, the transaction which you do while doing an algorithm and all, it should be lightweighted. That's how I will distribute it.
Okay, that's great. In the similar line, what we have observed is when we want to integrate these data models in embedded, we need to train that, right? So the accuracy of the outcome is highly dependent on the amount of the data that we are going to train. So as you rightly said, we have to be very constrained in terms of memory because it's an embedded system. But when it comes to the training and adaptive training, because suppose the data set is always going to continuously change. So do you see any other challenges doing this adaptive AI?
So for training, typically you have to rely on certain certain subtle algorithms. Typically, I would go for neural networks, which are low computing, lightweight. I will prefer that so that the data and algorithm is not heavy. It computes, it runs seamlessly. That's how I would prefer that.
Okay, that's great. Now we'll move to the next question. So what all challenges the industry face when we are deploying the embedded system at a scale and how they are overcoming these obstacles?
Yeah, thanks, Mahesh. I'll just start first from the manufacturing and then we'll get touch base on the design. So currently there were a lot of challenges that the embedded industry has been facing. And some of you, if you have been on the EMS shop floors, basically the manufacturing of electronic components, they start with the pick and place, they go through the SPI, then they have the AOI plus the end of line. So currently the challenges that we are facing, the industry by and large is facing, is when especially, I'll give one example of the AOI, where this is like an optical inspection of the components. If they have been placed at the right footprint, if the right part is in place or not. And many times it's been observed that since this is being taken by camera, the camera does not really distinguish even if there is a slight error of tolerance and or if there is an alternate that's been placed in that place. It gives a false alarm. And generally what happens, if there's a false alarm, it's a trigger and people have to take an action. And if that has to be happening, then it's going to be disrupting your flow. You have to wait, then decide. And if there's a decision made, the question is asked to the operators, what was the criteria, and then that's good documented, and then it gets into traceability. Now, the AI has come up with a plan where I'm seeing this implementation in all the machines that are being currently sold. They have a software in place where the entire library of components gets downloaded by the software, and the AI kind of makes decisions on behalf of operators, making sure the false alarms are reduced. So actually, this is a very good achievement if you ask me from the plant productivity and improvement point of view. So these are some of the areas, these are like low-hanging fruits, which they caught and they immediately implemented, and they even actually charging huge amount for that. But this is a welcome thing, actually. But if I get into areas in embedded systems where we have the challenges, like I think Sagar talked about one of the areas with the application layer. Similarly, in embedded systems, we are scratching the surface at this time. We have really not gone very deep. By scratching, I'm saying, let's see, we have models. The components, each component have their own piece-wise models. And let's say if I have to start simulating an AI model to see if this is going to be okay or not, then each component supplier may not be able to provide you the information that you're looking at, especially if you talk about microcontrollers. There are a lot of proprietary information that doesn't get out of the designer itself, and getting sometimes even for consumers or customers like us is a challenge. And I'm not sure how comfortably the people would be able to give this information openly to everybody. Some of that information is really IP that cannot be put out. So this is one challenge at that level where I'm talking about models. The other area where this is something that can change going forward, where I'll talk about simulation, but I'm also talking here about the testing that happens. So if you know all automotive testing that gets into 3 or 4 parts, you've got a pre-DV, then you have a DV, then you have a PV. So each testing has to meet certain requirements, and how can AI make it better? Right now, there's no way it can be done, because if the expectation is it should run durably, reliably, it should really show the performance, and the component variability, the reliability has to be established. So if it's a 3-month DV process, can the AI cut it down to a month? It's a question mark, because these are the expectations from the customer. It is like form, fit, and function. That's one part. The performance is the second. And the performance part needs to be evaluated, and that data has to be maintained so that for any future issues related to that part has to be addressed. So this is the other area where I feel the challenges can be there. It could be mitigated by ways like, you can, the AI can have it can develop a rule where, you can say, okay, if this is the percentage of, let's say if you talk about conducted emission test, and if you have met that conducted emission test or a radiated immunity, it can derive saying that, okay, if these two tests, probably radiated emissions may not have issues. So you are green, the confidence is very high. The decision can be taken by the designer whether to do it or not. But again, these are all questions that can be addressed when that time arises. So generally, I think modeling part, correlation part will be a challenge. But on the manufacturing side, I think there are huge opportunities already being addressed and a lot of already being implemented. And I see even more opportunities there.
Thank you. Thank you, Sachin.
Sachin, thanks. I wanted to share my perspective coming from my previous organization where we were heavily designing a lot of generative AI models. So I'll just give you, this is with context to the automotive. Now, 2 points I wanted to touch upon. One is you mentioned about whether we have the data. So most of the geographical, including India, we have a data protection laws, which is coming very heavily. Now, to train a model, first challenges I see is a commercial challenge, because you have to put more than, when I recall my last interaction for a one language model, which was based on the generative AI, the voice assistant for a specific language, let's say in India, we speak a lot of languages. Let's consider about Hindi. So for that, there is a huge amount of investment to make that model up. Now, we do not have any benchmark against which I have to test my model. Now, I will be relying this solution going into the market. And then I will getting a very bad feedback from my customer that, okay, I purchased this car, but this model on a communication is not working. Then again, it will come back to the ecosystem. Another challenge I see after investing this much heavily on the commercial, we are still not sure whether my model is working and whether I will get the efficient data to train or retweak my model so that I test it again in the market. So these all are multiple level of challenges. It could be commercial challenges, data related challenges, data privacy related challenges. There are a lot of things are there. So I mean, it's not that easy to design a model and roll out in the market unless you test it. Sometimes your test getting successful at your lab, but when you go a vehicle or any other, the domain in which this kind of things are operated, whether that is successfully carried out, it's a journey. Yeah.
That's correct.
Yeah, correct.
And it's even more difficult if you go to the design models, like piece-wise, let's say if components, piece-wise models for all the components, especially, let's say if a company is manufacturing this part, and let's say MOSFET, and another company is also giving out its piece-wise models openly. So that's going to be a direct, way where people can see each other's information. So every company has its own IP, how they manage, how they design. So that is where I would, in addition to what Sagar said, I think maybe there will be something that will come in the near future that will address that point. Maybe it will be more superficial. Maybe there will be accuracy might be lesser. It may not get you the 99% accuracy. Maybe talk about 70%. Or maybe AI can talk about confidence levels, like what we talk in statistics, or a probability. So maybe those things may evolve.
Thanks, Sagar. Thanks, Sachin. I think this is what, as rightly discussed, we are in a very primitive stage of AI implementation in embedded. Obviously, there will be a lot of challenges in future, and obviously, we are going to solve it eventually. We don't know the time, but eventually we'll solve it. Yeah, we'll move to the next question. How can AI-powered embedded systems ensure robustness, reliability, particularly in the mission-critical systems?
Hello everyone. So I am from the consumer durable industry. So I would like to restrict my answer and explanation based on that domain only, because AI is a huge application in all the domains. So one may conflict with other. As we talk about the reliability and performance of AI embedded system in the consumer durable, because AI is being used is as a one rich source of whole database. It uses the previous all kind of errors and self decision making for not making error again. So we are going to add all these kind of coding and application in AI embedded system to increase the reliability of the product and better solutions what we are giving right now. The performance, what if we talk about, if any system is there, right, which is balancing itself and self-optimizing through the previous data and through self-managing the system, so it is going to create a new, better product which is going to give a better performance for the consumer. So that's all thinking about the performance and reliability. And what others talk about the challenges. So personally, I believe, based on my experience in the industry, every system for survival, it requires one standardized ecosystem. So for the AI, it also required AI edge ecosystem, where we are, as a creator, we are creating the product. But if it is not properly handled and standardized through the whole industry, in terms of what we can say regulation, compliance, and everything, then it will create a one kind of another trouble for the whole industry and all consumers. So this is the one of the biggest challenge for the industry what we are facing as of now. Developing a whole AI edge or AI based ecosystem for the consumer durables.
Correct. Thanks, Ved. I think that was correctly said. I think, Sagar, do you want to add anything? Because this question was more related to the mission critical applications where everything matters.
Yeah, so you touch up the very last good word, matters. So even in Wind River, we have a tagline, when it really matters, it runs on Wind River. So whatever we do at Wind River, it's all mission critical. So our day in, day out, the solution is focusing on the mission critical, considering all the mission critical, including the avionics, defense, the software defined vehicle for the autonomous vehicle, and lot many other critical industries. So I would like to touch upon three words. And I have one question for audience as well. So there is two words in AI is very much buzzing. One is generative AI, another is the agnetic AI. So is there anyone who's working on agnetic AI model in the audience? Okay, so if not, I will just touch upon. So it's like the intelligence side of an AI, which is little beyond the generative AI, which actually does the intelligent identification and do the intelligence execution of a task. And you don't needed a human intervention. So if I relate from the automotive industry, so if we nowadays we do a lot of buzzword of software defined vehicle and autonomous vehicle. Now in autonomous vehicle, since you all rely on the sensor and the intelligence algorithm, which is running on the processor high computing environment, so I would consider this as a mission critical because it has a direct relevance with the life threat. If that autonomous vehicle will not be functional as is intended, then it is a problem. So considering the agnetic AI, I only share my perspective, even though industry is, no, I mean, boosting around on the SDVs part, and they are doing a lot of investment on agnetic AI, generative AI, and a lot of do this thing. Only my question here is, since I touch upon my first question answer is that it is not possible and never going to be accepted at the OS level. But if you are working on the middle layer and the top layer, these all are good. The only question is, or we need to ask to the regulators, are we going to come up with any policy or guidelines or regulation which revalidates the model which I invented? So every next company who might be working on this model will be following the same practices. So this is one thing. Another thing is why I raised this question about needed framework. Sometime back, if I'm not wrong, in China, there was an intelligent robot. It does all tasks automatically and it has malfunctioned. It was a lot of AI was involved and it has killed the human. So that has triggered a lot of issues. Are we really going to rely, if an autonomous vehicle is running, are we going to give a sideline or are we still ensuring that it will function accordingly? So these are ifs and buts, and you need to ensure, even though if we are adapting, it is very difficult to adapt in India, looking at the diverse road condition and a diverse pattern of our individual, it is difficult. But at the global scale also, if you think to adopt this thing, then you need to have a framework, just like what we have a software framework, functional safety and everything in every industry. You should have a AI model which has to be validated, and all the participants should follow those things. So this is my perspective. Yeah.
Thanks, Sagar. Thanks for your insight. I think we'll move to the next question. So what all strategies can industries adopt to overcome power consumption, latency, and scalability challenges in AI embedded systems? Okay. How can AI system predict potential system failures and optimize performance, particularly in critical applications? How can AI system predict potential system failures and optimize performance, particularly in critical applications?
Yeah, as I explained earlier, it's a self-decision making systems are there. So AI embedded system, it takes the decision based on the data or the trained data to the whole system. So it creates a one kind of reliable and safer environment, whatever product it is there.
Okay. We'll move to next question. How can AI enhance the safety and reliability of embedded systems?
Yeah. Thank you, Mahesh. So, for any system, we whatever the safety requirements are there, so that can be enhanced through the data. So, for the AI, the basic input is the whatever the data which we are giving as a input. So, real-time monitoring of the data, so that can be a very helpful to improve the current systems. So this real-time data which we are generating through the different sensors and whatever the equipments we have. So then the second thing which is the predictive maintenance. So this data which we are getting from the different sensors, so that can be used by the AI to predict the failures of the different equipments, and that can be used to enhance the safety requirements. Thank you.
Yeah, that's good. Can you just give me some example of predictive maintenance that can, AI in predictive maintenance that can improve the life of the system or the overall performance of the system?
Yes. So, like in machines, we have the motors. So, this real-time data from the temperature sensors and the load monitoring systems. So that we can take into the AI, and that will help us to give the tolerances there. And if it is going beyond certain limit, we can give the alarm, and we can avoid the breakdown of the system. So as per our convenience, we can give the we can do the maintenance of that system, and we can keep that system running for our job, and that productivity can be achieved through that.
Correct, yeah.
Just wanted to add something on top of what Nilesh said. See, you have per component reliability data. So you can train your model using the reliability data. That is the first stage. Second stage is throughout the lifetime of an appliance or any device or any subsystem component, either it is motor or any belt or anything, you can train your model or track the data, how it is behaving, either it is current, voltage, vibration, and as soon as it starts behaving something differently, you can trigger the alarms, you can raise the request that something is going to happen in near future. That's how you can certainly resolve or handle the predictive maintenance.
Yeah, thanks.
I would like to add here, actually it is all going to be through all AI embedded system. So the counting and maintaining all those things would be easier, and the chances of error will be reduced if we add all these things for the in the product.
Correct. Yeah. But still, I have seen when we talk about the industry 4.0 and all, the primitive sensors are embedded only, and the next layer is actually AML, which analyze the data, and then it will tell whether this particular motor is having the bearing issue or what kind of issues it has, how many times is on or uptime it has. So we clearly see that AI is not yet completely adopted in the embedded system as of now, but in near future we'll have some solutions in that regards, right?
Just wanted to touch upon two aspects. I'm sure out of this audience, many are coming from tier 1. And most of the OEMs look this as one of the lucrative way to sell their vehicle. Like mostly they are working on, I'm not sure about India, but at the globally, we normally talk about the predictive maintenance and predictive AI, but there is another concept called proactive AI. So I'll just give you an example. Like these, so there are two ways to look at why this is getting adopted or this will get adopted. Reason being, it will enhance the, so one use case is like if you're driving a car and you have this predictive maintenance or algorithm in place in your car cockpit, then it will give you an indication, okay, your fuel is about to, it's like, no, you have not inquired for that or you're malfunctioning some of the parts. They are giving you a proactive information back. That is one of the use case of AI. But on the other side, when I'm mentioning about proactive AI, which is different than the predictive AI, so in some of my earlier organization, for a global customer, there was a concept incorporated in the cockpit for proactive AI. So I'll give you one simple life example. Let's say right now we are sitting in Pune, Viman Nagar, and we might have to drive down this car to Hinjewadi. Okay. Now, or maybe let's say Bombay. I'm just keeping another city. So I have just started I have put the Google location and I've just started my driving. So proactive AI, how it is helping and giving a more comfort to a driver and as a luxurious vehicle, why this is getting adopted. Proactive AI will sense what exactly location I'm intending to drive across, and they will sense the entire journey in between. Let's say there might be a shutdown on the road at the nearer to Pune Bombay highway. They will upfront give you an intimation to the driver. Another thing, there might be a worst weather coming on the way. So that proactive AI will have those sensing. It's touch upon the cloud and a lot of other no, the weather related integration, but they will give you an insight. So these are some of the feature which will help you predict certain thing. Some of the another use cases is like there is an urgency ambulance is coming very at a high speed on a different road and you are just driving across. But if you are getting this kind of upfront, you will be slowing down on vehicle. And these are sensing from a very large distance. So these are some of the use case which we work for a global customer in a regular organization. So people are working on proactive AI as well. So AI is getting adopted to give more comfort, more security to the driver and enhancing the in-car cabin experiences.
Thanks, Sagar. Thanks for your experience.
I just wanted to add on the challenges of
Yep.
adopting AI. And typically this is my help experience coming from home appliances background. See the designs, the components or the chipset, the entire design, the ACUs and MCUs or the chipset which we are using have been there or the hardware has been designed for last 5-6 years or it is old typically. And we are continuing with that. Though everyone is aligned to adapt to AI, but the investment should happen to redesign the chipset or redesign the entire hardware is not there, and the cost assigned to it, aligned to it, that to change the entire hardware is really higher on higher side. So it will take certain amount of time or time and cost and money to go to or adapt to the AI solutions because it needs complete change. The alignment is there, but the investment should happen there.
Correct.
Without that, it's going to be challenging for at least next couple of years.
Correct. Yeah, thanks. Any questions from the audience side?
Hi, I'm Dr. Anand Krishna from Millennium Semiconductors. Yeah, my question is to Mr. Sachin. See, you mentioned onto the DV and PV part of it. There is definitely I see a lot of a gap where we need to understand the kind of concepts, and with respect to the testing perspective or a certification perspective. When I mentioned towards that, whether it is going to be with respect to the EMC or a safety or environmental or reliability or cybersecurity or AI part of it. So there's a huge amount of regulatories which is going to be mandatory in the near future for sure. But having mentioned that, how do you think that AI can able to pitch in, and there is definitely a technical layer on top of it, an AI layer will come. But how do you think that, like, what are the challenges? How we should be looking at, in what perspective this layer can able to be built in?
Yeah, thank you for the question. Actually, there has to be a structure within AI which has to be correlating to the standards that are in place. See, as I said, AI can only start telling you about the confidence level and the probability of this test getting okay. And this will be based on the data that we feed in, based on the first level test. And many times, if I go one level lower, some of these decision making can also be incorporated in the AI itself. Like, if certain tests are correlated, that we all understand. And if we say that, okay, 2 out of these 3 tests are okay, then it's good to go ahead. And that is going to give a confidence. But the regulatory part has to be looked at. Because if the ARI certification says, unless you pass all, I'm not going to give you a certificate, then it has to be amended in a way that it doesn't talk about the count of tests, but the functionality of the product, that this is going to be meeting the intended function. And then with that, probably certain modifications may have to be done that will reduce the lead time. See, the intent here is to cut down the lead time for, let's say, for DV, which we say is 3 months right now, to a point where, it is an acceptable time, let's say 45 days or 30 days. So I think this is my view that, this is something that can happen. But again, this has to be a defined structure. It cannot be arbitrary. It has to be adapted, debated, and only then it's going to be implemented. Otherwise, OEMs will always have this question that nobody wants to take that risk. And this is a mandated requirement, let's meet it. The other part, which you have not asked, is the vehicle testing. Right? After this, we are going to run another 50,000 kilometers or 10,000 kilometers. How do we get that also in place so that there also we get some reasonable confidence with all the parameters that we monitor and reduce that or optimize it? Not reduce it, but optimize it.
Yeah, but definitely whatever the points which you mentioned, I completely accept it. But all these things, we need a data, right? Data is going to be the
Exactly.
backbone of it. And if you don't have a data, because all the OEMs, I don't think so anybody wants to step up and say that, like, hey, I'll step up and provide this AI solutions to you. Definitely we need some of the inputs, but the data is going to be the key aspects of it. So that's something which is a little more dicey in order to, that is the step where we can able to start developing this AI platform.
Yes, you are right. Because nobody is going to share their results with somebody else to say this is what happened. It has to be done independently on different platforms. So we can do a modular design. Let's say we just focus on modules. Let's say talk about power supply. Okay, what does the power supply design include? And what are the challenges that it will face? And then we all know what components are required. What kind of filters are needed there. What kind of reverse voltage protection is required. Focus on those components and then try to derive a decision and then say, generally, if this is the kind of complexity, this is the kind of confidence level. And of course, if you go into much deeper designs, if you talk about fuel system design in an embedded systems, this is not going to be in AI in any case, because right now, of course, the diesel engines and all, they are getting faded out. But yeah, at least till the time they go away, this will remain.
Thank you. And one more question, if I can ask.
Yeah, please.
Yeah, this question is to Sagar. Sagar, you were mentioning with respect to the regulatory aspects of it with respect to AI, and I just wanted to understand, right now I come across, one is with respect to 27001, which is predominantly to the information security management systems, and also one of the standard which says about like the artificial intelligence management system, right, that is 42,000. So with respect to the specific industry, let's assume that like if I wanted to focus, say that like, AI with respect to the automotive or with respect to a medical. So is there any kind of a standards evolvement or the regulations evolvement which is being happening? Anything which you have seen with respect to an international market and you wanted to throw light on it?
Okay, so as I mentioned, as far as I know, I'm just taking consideration as an automotive industry. There are two emerging thing automotive industry is adopting is on the UN regulation, which mostly talks about the cyber security aspect. Because this also covers some portion of AI. Because what happens, there is one algorithm called CSMS. It's a cyber security management system. Okay, and there is a specific standard also, UNR, if I'm not wrong, UNR 155, and there is upcoming standard, which is a little derived from that global standard in India for an automotive is, I think, AIS 189, which is about to come, and there is a AIS 190. Now, there is another subset of that in UNR 156 talks about SUMS, this is Software Update Management System. Now, how this is relating to little AI, let's assume it could be any industry. There is an edge device. You wanted to take some intelligent decision. So you will be grabbing the data and doing some analytics at the cloud. So in vehicle as well as in aircraft industry, we call it as a digital twinning. That means you are trying to get insight of what is running at the edge, pull those data, do some intelligent AI algorithms at the cloud, and then you do some action. Let's say you are doing a down action, that means you might do some action and update back to the vehicle. So that becomes a bi-directional connectivity. Now, you are doing something AI at the cloud, and you are doing. So that is where the SUMS standard is there, which maintains that you need to ensure the cyber security layering when you do the updates back to a vehicle. But when I talk about the AI, with my limited knowledge, I am not sure, are there any guidelines are there or standard are there for generative AI or agnetic AI or any AI model, which any of, irrespective of the industry, which people are working. So I am doubtful. My only take on my initial thought process is that you must have some guidelines or a model or a regulatory aspect so that everyone who is working on those model are following the identical practices, and also you will get a validation from the regulators.
Yeah, as I understand, there is NABCB is come up with the kind of I mean, they are following the similar kind of 42,000, which predominantly talks about artificial intelligence management system. Any organization, whether it is going to be the fintech or automotive or any other industry, textile or leather industry, anybody wanted to say that like they wanted to AI compliant, they are saying that like you have to follow this kind of standards. That's with respect to Indian perspective. But when it comes to global, right, we are always fascinated about like, what are the global standards are we going to meet when it comes to AI compliance as part of it. So as I come across with respect to this, IEEE 299 is one of the standard which clearly talks about like, but that's an initial. But that is not an accredited standard which I can able to say. But any other standards or accreditation bodies which is coming up in this particular directions, because all this going forward in the near future, AI and the cybersecurity is going to be the key critical any of the product you take about it. So because one or the other way it's going to connect to each other, to the cloud or in any other means which is there. So these are the critical aspects.
So I have not come across, frankly speaking, but now your explanation and that particular standard which you have referred has made a curiosity question on my mind. Now, you mentioned that artificial intelligent management system, irrespective of the industry. Now, we need to also think, suppose you follow that standard. I'm just giving it a get, we get a confirmation from our industry that, okay, you can able to follow that standard and we are going to accept that thing. Now, you need to also ensure whatever is the model you have developed, it is for which use cases. Let's say, for example, there might be one use cases which Vishal mentioned that he's working on an intelligent refrigerator. Okay, and maybe some algorithm he mentioned at a cloud, some operation came back to refrigerator. But it is not going to be, I would say, the life-threatening. I mean, the action which refrigerator will take after following this model. Now, consider this aspect to a vehicle, and that to an autonomous vehicle. Let's say there might be some mistake or some might be loopholes in the standard. You develop the algorithm, you have done all the insight, you are making that action back to a vehicle. And now after that vehicle will do some malfunctioning and it might hit to some and it might be life threatening. So that we need to see. We need to understand the use cases. Also, we need to understand that, let's say there is an bird view eye of any model. It has to be drilled down to a very specific industry and a specific use case. I cannot use the refrigerator model kind of a guideline for an aircraft where I need to have a mission critical response. Like if my missile has to hit at this point, it requires and it has to take an intelligent decision by seeing certain things. So there is something, no manpower is involved and there is some AI would be involved to take an intelligent decision. That is where I touched upon one of the buzzword called agnetic AI. So, I mean, I still would not in a favor to use any intelligent decision making for a mission critical operation, irrespective of the industry, to be used by an AI, unless we have to revalidate again and again at the ground level to ensure that it is functioning properly. Otherwise, it would be a very difficult situation. And one example which I took in my earlier explanation about the robots, which it was running all AI, some malfunctioning has happened and it has killed the human. So yeah, so that's the sad part of this. Yes.
Thank
I
you.
hope I would able to touch upon some
I
of the
think
areas.
Predominantly, I think I got the kind of an answer, but still the kind of like, the gray area exists. The reason is that like, there is no such kind of a standards which we have come up with, or the regulatory or the standards at a high level. One. Second is that like the next domain level, the functional level or the testing level, which is definitely a major ask for the countries, not only for the country, for the world. But I see that like, because as long as we are not going to define this kind of an infrastructure, it's really going to be difficult. And it's going to be a contribution not only from the industry, from the regulatory bodies, and from the government. That's what my answer. Thank you.
And just last point on your last statement, there is a possibility that let's say we even try to adopt some of the frameworks, but then we have a different regulators. There is a different regulator for automotive, there's a different regulator for medical, there's a different regulator for avionics. There is a high possibility, looking at the sensitivity of the work task or the action, it might not be accepted, or it might need a further fine tuning. So that's ifs and buts always there. Yeah.
Thank you so much.